This video is a little demo of what bezier is, things I did, stuff like that. So say you have two end points, the black ones, and then control points. So the way you find a bezier, let's choose, we'll do the gray is fine. We'll do blue just for kicks. Okay, anyway, so we have a line from here to here, and then we have a line from here to here, and a line from here to here. Oh, come on, paint. Alright, so we have some lines. So with this line, I can find an arbitrary point along this line by thinking of a percent. So the point 50% along the line would be about here, 25%, 10%, 33%, whatever percent you want, you can find a point along the line. So let's do 50% just to keep it easy. Go back to brush, make sure we're there, and we'll do what? Orange? Sure, orange. So 50% along the line is about here. 50% along the line is about here and here. Now what we can do, is let's do two more lines from here to here and here to here, and recurse. So go back to brush. 50%, 50%. Yeah. And we'll do one more, I guess green. And we'll make this one darker because this is the important one. So once we're down to one line, that's our point. So for 50% of this craziness, that point. And you can use just one control point if you want, and it works. If you have more, you just need to recurse more until you're down to 1 point. So just to kind of prove this out, let's do, I don't know what color. Can't think. Blue, I guess. Now we'll do purple. Okay. And do the curve and 1. So, draw a line. First control point. Second control point. And look at that. So this curve tool, I should have used, can I make it darker? Yeah, I can. So this curve tool uses beziers under the hood, and it's hard-coded within Microsoft Paint. It's hard-coded to use 2 control points. 2 is usually, it gives you good results and it's easy to use, but you could use an arbitrary number of control points. So that's all they did, is they just took many samples. It's tough to do for a person, because it takes forever, but for a computer it's fast. So notice that a bezier will always go through the endpoints but never through the control points. Well, not never, but essentially never. So what if I wanted another, let's draw another endpoint here. And fill it in. Okay. So what if I wanted another endpoint? Well, just create another bezier. The problem is how to define the control points. I can't think. So let's just draw a line. I'll just show you. Blue, 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 blue. So as long as we'll do this color again. So as long as the control points, is that about right? Yeah. Set you back down. All right, and then we'll do purple again. And I need to draw this in order, so yep, this one. Oh no, oh, come on. Come on, paint. One more time. Draw you. click away and commit. Now click on bezier and click on my color. So I have my bezier, and the first control point I can set wherever I want, right? I'll just set my control point here. The second control point, as long as it sits somewhere on the line between this control point, this endpoint, and then the path will be smooth. If I sit outside that line anywhere, the path won't be smooth. It's messed up right there. So we'll just choose there. So now we have a bezier, well, two beziers, but we have a smooth curve through points. So let me just pause for a second. All right, I don't have a good visualization of how I chose those control points, but this tool, or this attempt, I'll just jump into it. Tough to describe. So if we look at this one, so this mess, that the stop, well, it doesn't matter. So these black lines, these black circles represent endpoints of beziers. So we have one bezier, another bezier, another bezier. No, so 1, 2, 3, 4 beziers here. Notice, so this plot is kind of a mess, but these green and red lines are 12. So there's 12 sample points for this, 12 for here, 12 for here, 12 for here. Notice that there's a lot more here. That's because this overall line segment is smaller, and so they bunch up. So what I wanted to do was create uniform distribution of points. And that's what these gray dots are. I have other visualizations that show this more clearly. But notice right here on this pinch point how there's a gray dot, gray dot, gray dot. And it's like really jaggy right here. So that's what all this coloring is all about. I took dot product of this line segment and this line segment. Take the dot, subtract from -1. So -1 would be 180 degrees. So if you're 180 degrees, that means you're a straight line. Any dot product greater than that means you're a more pinched line. 0.3 seems to be, or the difference. So that would be -0.6. But anyway, that seems to be like super in practice. So this was a plot. This was an attempt. How do I say this? I was trying to figure out how to basically put more points around the pinch points and fewer around the dead zones. My first attempt was create an arbitrary number of divisions, sort of like bars, and then I used the dot product as a height. What did I do? Well, I normalized it 0 to 1 here, and I like basically find the area of it was a mess. Tough to describe. But anyway, using the bar, and I commented the button out, and I've commented the code out. I've gone through so many attempts, but that was a failed attempt. Long story short, the bars matched the density of the sample points. So I realized that instead I needed, oh, that's what these are for. Okay. I realized instead I needed to think more analog, not discrete bars, but more analog. So then I was trying to figure out, okay, well, I'll make a bezier. Notice that we go green to red, green to red, green to red. So green is a point of lowest pinch. red would be a point of highest pinch, and you just kind of alternate between, or there's always a green between the two reds. But then the end of this mess, we're on a red stroke. If we continued on, that would be a green stroke, and I didn't even get into closed curves yet. Then it occurred to me, I don't need multiple Bezier segments this will all make sense. I have a visualization here. I just don't. This was another dead end, so I don't have a visualization. I can do all this with one Bezier segment, way easier. So let's just do that. What are we doing? I think that was it. Oh yeah, that's it for this one. Then we go to this one, and this got nuts. So here's our sort of control panel. I'll just do this real quick. So I'm using these two endpoints. So I have a Bezier, and if I drag up and down, X doesn't matter in this case because I'm using this Bezier and I'm taking only the Y coordinate of that. So that's what this little plot shows. If I take 12 uniform samples from here to here, and then I run that through the Bezier and take only the Y coordinate and treat that like a percent, total percent, then I get this weird pinch. Another way to visualize, so let's throw this off. Okay, another way to visualize what I'm doing with these points is I take this Y position minus the Y position at this percent. So this control point is 33% along this curve. So at 33%, this minus this gives you the height of this bar. If I'm above the line, that means move to the right, and this will make sense. Well, I guess you can kind of see that. You can kind of see that here, right? So if I'm uniform, let's just do 1. So if I move to the right, you can see it pushes influence to the right. If I move to the left, pushes influence to the left, and then I can create an arbitrary number of these things to try to place influence. So you can imagine there would be pinch points somewhere, right? So I can try to fine tune. So let's do random sample. Actually, I'm going to zoom back out, move all this mess out of the way. Actually, this one I don't care about. This one I will care about. Random sample. Now let's make. This was a bad example. Yeah, this is attempt fail, attempt fail, attempt fail, just for a month. Like it's been nuts. All right, so we have let's throw another point in here. 2 points. So purple is on the right. All right. So notice how when I move this up and down, it changes where the points go. So if I wanted a higher density here, then I would take from these flat spots and put it here. So I move some points up here, and now there's too much down here, so I push these left. I can just kind of play with it until I get something that, kind of eyeball it. There, that looks good. Right, not perfect, but. So let's do another random sample. No, not random. Yeah, random sample. Yeah, here's kind of a mess. So this is made of, get rid of you and you. All right, so here is what the uniform, if I were to choose uniform points, the distance between each of these black lines is the same across all these points. And you can see at these pitch points, it's pretty bad. And this is the corresponding graph. Which one's start? That's stop. So start, So when I say of, 0% along the length of this entire curve, right? Sorry. So let's just try to do that. Let's match. So we'll put brown on top. Up there. There we go. Now everything kind of matches. So use brown. Pull this way. Now I need this way. And notice I'm trying to get this. But now I'm robbing from here. So we need more knobs basically, so let's double it and try again. So here, and do that, and then give some back, right? So like I can fiddle around and get, okay, so now I have something nice here, but I've kind of messed this up, so I'm gonna have to do similar things. Pull these left, pull this one left, right. So now these two are kind of fighting with each other, right? So I can get kind of close, and I only have I think it's like 36 points. But notice that in the middle, so I would need more points, and basically, and this is kind of where I stopped. I realized that this would be an iterative process programmatically. It has to keep trying. I was thinking maybe start with one node, do the best you can, and then if it's not good enough, then split, because I never did it. If I type 7, it'll but if I type 7, I could probably create 7 control points that keeps this curve. This is another plot I did to try to show influence or whatever. I was in the middle of writing the piece that does this, but then I realized that again, this is way too complex, way too iterative. If you go back to I'm gonna close all of this, start this thing over, pull you up again. I don't care about you, I only care about you. Okay. I'm just going to show it. Simple fix 2 with 4 points. Where'd we go? So, actually, I do need these are probably about even. Yeah, so in this case, I have one segment, one segment, one segment. So 3 segments, and they're all about equal length apart. So notice everything I was trying to do, it looks great right here with just 12 sample points. And if you wanted 48 sample points, then just imagine you'd have 4 times as many points, and it would look even better. It's all evenly distributed properly. The problem is when one of the line segments is drastically smaller than the other. Nope. I'm just going to keep hitting this until I find a curve that. Yeah, here we go. This little bow tie thing. Actually, it's probably looks better if I do it this way. So notice that But see, even this looks good. And that's the other thing is the way I calculated the pinch points or the control points for this curve. I'm rambling. Anyway, that's where it's at. Basically, what I did was let me find a better example. There's got to be a better example. Actually, I will pause while I'm finding a better example. Here we go. I just realized that I need to go. But notice how these points are nice and tight, and then all of a sudden, super bad. It's way off. It's partly due to the length of the line segment, but also the way I chose the control point. This has a control point probably around here, and this one, yeah. And so what this fix does essentially is it this uses 12, 12, 12 for every line segment regardless. Well, what this fix does is it simply redistributes the count per sub bezier and applies that. Yeah, here we go. So this yellow is the uniform, this white is the pinched or the redistributed, and you can see it's still not great, right? There's a bunch of points and all of a sudden, but visually, if I got rid of these dots and all you saw were the white lines, it would look nice and smooth while still giving low influence to the straight lines and high influence to the pinched lines. It's not perfect, but it's good enough, and I've been working on this way too long. So that's beziers.